The refraction of light can create many beautiful optical illusions. Suppose we change the shape of this lens. Let's now return to our original shape. Suppose we change the location of the objects. The image can either be right side up or be inverted upside down. A beam of light is composed of particles called photons. Photons are very different from the particles that matter is made out of. The speed of light through empty space is the same for all observers. But light slows down when it tries to pass through certain materials. One way to view this is by saying that the speed of light has not really changed, but the photon is constantly being absorbed and re-emitted by the atoms of the material. And the delays between the absorptions and re-emissions is what is responsible for the apparent slowing of the light. Parallel beams of light passing through this lens will exit moving away from each other. If we trace their paths backwards as straight lines, then the location where these lines meet is what we call this lens's focal point. Parallel beams of light passing through this other type of lens will exit moving towards each other. In this case, we call the focal point the place where their paths meet. We're now ready to understand why this lens can flip an image upside down. Consider the paths of the light beams passing through the lens that come from the objects. The image appears where the light beams appear to be coming from. If we change the location of the objects, the size and location of the image changes as shown. This image will appear to be in front of the lens, and it'll be inverted upside down. Let's now move the objects very close to the lens. The lens is now no longer able to cause the light beams to converge. Let's trace the paths of these light beams backwards as straight lines. The place where these light beams appear to be coming from is where we will see the image. In this case, the image appears to be behind the lens, and it's no longer inverted upside down. All this has been done by just moving the location of the objects. But what if we also change the shape of the lens? As always, the image will appear where the light beams appear to be coming from. Here, the image appears to be behind the lens, and it's not inverted upside down. Suppose we now change the location of the objects. The image will change as shown. So far, we've only been talking about lenses,